So we're going to be working on Chapter 6, Lesson 3, Solving Multi-Step Inequalities. So what we're going to learn in this lesson is how to solve linear inequalities involving more than one operation. And we're going to be learning how to solve linear inequalities involving the distributive property. So in the previous two sections, we've covered how to solve using addition and subtraction. And we've also learned how to solve using multiplication and division. So now this is going to bring it all together where we're going to be using more than one operation and also problems involving the distributive property. So as we move through here, how are linear inequalities used in science? So it says the boiling point of a substance is the temperature at which the element changes from liquid to gas. The boiling point of chlorine is negative 31 degrees Fahrenheit. That means chlorine will be a gas for all temperatures greater than negative 31 degrees Fahrenheit. If F represents the temperature in degrees Fahrenheit, the inequality F is greater than negative 31 represents the temperatures for which chlorine is a gas. If C represents degrees Celsius, then F equals 9/5 C plus 32. So you can solve 9/5 C plus 32 must be greater than negative 31 to find which temperatures in degrees Celsius for which chlorine is gas. Again, they give you the boiling points for each one of these different ones. So that's the way you can use linear inequalities in science. So solving multi-step inequalities. If we took the inequality from the last example, 9/5 C plus 32 is greater than negative 31, it involves more than one operation. It can be solved by undoing the operations in the same way you would solve an equation with more than one operation. So again, making that connection between how we solve the equations and how we should solve inequalities. Again, you can see that it's 9/5 times C, so there's multiplication as an operation, and then it's plus 32, there's a second operation. So those are two operations, right? So solving a real world problem. So it says find the temperatures in degrees Celsius for which chlorine is a gas. So if I took the original inequality here, right, from that problem, and I were to solve this, right, which means solve for the variable, get the variable all by itself, I would want to start by subtracting 32 from both sides, right, because I'm trying to get the C by itself, so I can start by getting rid of the plus 32, subtract 32 from both sides. Again, as long as you're making sure to do the same thing to both sides, the inequality will stay true. And whenever you subtract, the inequality will stay exactly the same, right? As long as you do the same thing to both sides. So that leaves me with 9/5 C is greater than negative 63. And then now the final part is to get rid of this fraction here, right? So right now it's 9/5 times C. How do you get rid of that fraction? You can multiply by its reciprocal, right? Instead of dividing by 9/5, you can multiply by its reciprocal. It makes it really easy because then they just cancel out there. Leaves me with just C, and then 5/9 times negative 63. That's like negative 63 over 1, right? Multiply across. And that would, when you simplify it, it'll simplify down to negative 35. So that would be my answer. That would tell me that the temperature in degrees Celsius for which chlorine as a gas is any temperature where the degree Celsius is greater than negative 35. When working with inequalities, do not forget to reverse the inequality sign whenever you multiply or divide each side by a negative number, right? We learned that in section 6.2, where if you ever multiply or divide both sides by a negative, then you need to make sure you flip the inequality symbol, right? So in example 2, let's solve this inequality involving a negative coefficient. So here I have solved negative 7b plus 19 is less than negative 16. So let's go ahead and start solving this, right? Again, I'm trying to solve for the variable, so I got to get rid of all the stuff around the variable. I'm going to start with this plus 19. How do you get rid of it? Subtract 19. Just make sure to do it to both sides. When I subtract 19 from both sides, that leaves me with negative 7b is less than negative 35. Final step here is I needed to divide by negative 7, right? Because that's negative 7 times b, so the opposite of multiplying is dividing. Divide both sides by a negative, but what happens when you divide both sides by a negative? You need to flip the inequality symbol. It needs to go in the other direction. So that would leave me with b is greater than positive 5, right? Negative divided by negative is a positive. And so that's how I would go ahead and solve this. So how do you check it? Well, you check it by checking solutions on either side of 5, including 5. So test a number that is equal to 5, test a number that's less than 5, and test a number that's greater than 5. So what if we said b was exactly equal to 5? Let's test it in the inequality, right? Put 5 in. Negative 7 times 5 is negative 35. Negative 35 plus 19 is negative 16. Is negative 16 less than negative 16? The answer is no. So obviously b cannot equal 5, which obviously falls in line with our answer there. What happens if we say, hey, let's let b equal 4, right? A number less than 5. Well, if we substitute that in, negative 7 times 4 is negative 28. Negative 28 plus 19 is negative 9. Is negative 9 less than negative 16? No, it's not. So that one doesn't work either. Let's try a number greater than 5, right? Which is what our answer says, like 6. If we put 6 in, negative 7 times 6 is negative 42. Negative 42 plus 19 is negative 23. Clearly, negative 23 is actually less than negative 16, right? It'd be further left on the number line. So that one does check out. So our solution set is that for all b's in this problem, b must be greater than 5. So number 3, writing and solving an inequality. So write an inequality for the sentence below. Then solve the inequality. 3 times a number minus 18 is at least 5 times the number plus 21. So here I have it. 3 times a number minus 18 is at least 5 times the number plus 21. So 3 times a number, right? 3 times n minus 18 greater than, because it's got to be at least, right? The smallest it can be is this, so it's got to be greater than or equal to 5 times the number, 5 times n plus 21. So let's go ahead and now solve it. If you notice, I have a variable on both sides of the inequality. I need to get it all on one side. So I can go ahead and start by just subtracting 5n, right? Or I could subtract a 3n, either way, but you just got to make sure you do the same thing to both sides. So I did minus 5n on both sides. Right, 3n minus 5n would leave me with negative 2n minus 18 is greater than or equal to 21. Then I'm going to go ahead and deal with this negative 18 here, or minus 18. I'm going to add 18 to both sides. Again, all the subtracting and adding to both sides will keep the inequality all the same. So this is going to leave me with negative 2n is greater than or equal to 39. Final step here, I need to divide by negative 2 on both sides. But what happens when you divide by a negative? Flips the inequality symbol. So now that's going to leave me with n is less than or equal to negative 19.5. Or you could have left it as negative 39 over 2 if you want to leave it as a fraction. So the solution is set again is that for all n's, n must be less than or equal to negative 19.5. Solving inequalities with the distributive property. When solving equations that contain grouping symbols, right, like parentheses, you first use the distributive property to remove the grouping symbols. Well, inequalities are going to probably work the exact same way. So here I have a pretty big problem here. 3d minus 2 times quantity 8d minus 9 is greater than 3 minus quantity 2d plus 7, right? So I really need to deal with these parentheses first, these grouping symbols, okay? So the first thing I would use is a distributive property. So I would distribute this negative 2 and multiply it with everything in the parentheses here. Here, you notice there's no coefficient, there's no number here, but this really is like negative 1. So really, I'm just going to distribute this negative to everything inside of the parentheses, right? Negative 2 times 8d, negative 16d. Negative 2 times negative 9 is positive 18. A negative times 2d is negative 2d. Negative times 7 is negative 7. Or you could imagine this like negative 1, right? Negative 1 times that, negative 1 times that. So here I am. So now I have variable on both sides. I got multiple numbers. So maybe the easiest place to start here would be to combine like terms. So I have 3d minus 16d. That's going to give me minus 13d. And then here I have 3 minus 7. 3 minus 7 is negative 4. Now I can go ahead and keep working. So now I have variable. I can deal with the variable being on both sides. So I can start by getting rid of maybe the minus 2d. Or sorry, I can maybe, or the 13d, either one. I'm going to add 13d to both sides, right? These will zero out. And it leaves me with 18 is greater than 11d minus 4. And then I'm going to go ahead and get rid of the 4 here. So the opposite of subtracting 4 is adding 4. So I'm going to add 4 to both sides. and that's going to give me 11d, right, on this side, 22 on this side. And then final step here, to get d by itself, I'm going to divide by 11. If I divide both sides by 11, that's going to give me 2 on this side, d on this side. So really what this is saying that 2 is greater than d, or really it's saying that d is less than 2, right? Remember, the mouth is always eating the bigger thing, so 2 is bigger, d is smaller, right? So I could go ahead and actually rewrite it if I wanted to, right? Because 2 greater than d is the same as d is less than 2, right? These two mean the same thing. If I'm going to flip the different things on the inequality, I have to flip the direction of the inequality symbol. So again, my final solution would be that for all d's in this problem, d must be less than 2. If you're solving an inequality and it results in a statement that is always true, the solution is all real numbers. If solving an inequality results in a statement that is never true, the solution is an empty set or no solution, right? Because the empty set means there's no numbers in there that can work. So let's look at a problem that would exemplify this. So here it says solve 8 times quantity t plus 2 minus 3 times quantity t minus 4 is less than 5 times quantity t minus 7 plus 8. So again, I'm going to start off by using the distributive property to deal with these grouping symbols, right? These parentheses. So distribute the 8 into this parentheses, distribute the negative 3 into this parentheses, distribute the 5 into this parentheses, right? 8 times t is 8t, 8 times 2 is 16, negative 3 times t is negative 3t, negative 3 times negative 4 is positive 12, 5 times t is 5t, 5 times negative 7, negative 35. And now I can go ahead and combine like terms, right? I have this 8t minus 3t, that's 5t. 16 plus 12 is going to give me 28. And then I have minus 35 plus 8 is going to give me minus 27. So here you can see everything kind of simplified out. 8t minus 3t is 5t. 16 plus 12 is 28. And then if I subtract 35, add 8, that's minus 27. And so now again, if you see I have variable on both sides, so I want to get rid of one side or the other, so I could go ahead and subtract 5t from both sides. Now if you notice, they both have 5t, so when I do 5t minus 5t, that's going to zero out. 5t minus 5t on this side is going to zero out, and it's going to leave me with 28 is less than negative 27. Now, is that true? Is 28 less than negative 27? The answer is no. That is a false statement. So if it gives me a false statement, right, this is never possibly ever going to be true, that means there is no answer. There's no solution, right? The solution is empty because there's no numbers that will ever work. So since the inequality results in a false statement, the solution set is empty. So this little symbol, that's what that means. If for some reason this was flipped, and it said like negative 27 is less than 28, that would be a true statement, which would be the opposite, which means that all real numbers work, because no matter what, it's always going to be true, no matter what number you would put in for t. So if it's a false statement, it's an empty set solution. If it's a true statement, it's all real numbers, because it's always true. All right, thank you guys for watching. Let me know if you guys have any questions.